Thank you for the time. My name is Delfli Bobi Abdul. I'm working at North Sulawesi Research and Development Agency, Indonesia. Today I will discuss about our research with the title UV absorbing substances in the Indonesian starfish Arcastor typicus. UV radiation is one of the most harmful exogenous agents and may affect a number of biological functions in all sun-exposed living organisms. UV radiation contains UVA, UVB, UVC, and vacuum UV. UVA causes suntan and skin aging. UVB causes sunburn and skin cancer, while UVC and vacuum UV mostly block by oxygen and stratospheric ozone. Marine organisms living in the shallow water ecosystems are potentially exposed to the highest and harmful levels of UV radiation. Therefore, they have evolved the capability to biosynthesize, accumulate, and metabolize UV-absorbing substances as part of the overall strategy to diminish the direct and indirect damaging effects of UV radiation. Arcastor typicus is a common starfish found in tropical and subtropical coastal areas of Indo-Pacific Oceans and Ishigaki Island, Japan. This organism is a medium-sized starfish with radius between 15 to 40 mm, consists of central disc and have 5 tapering arms. Arcastor typicus live in the shallow sandy environment and therefore is exposed to the highest level of UV radiation, suggesting that this starfish contains UV-absorbing compounds to diminish the direct and indirect damaging effects of UV radiation. The objective of this research to isolate UV-absorbing substances from the Indonesian starfish Arcastor typicus. The specimens of Arcastor typicus were collected from the shallow water at the low tidal phase in Tongkaina, located near Manado Bay, North Sulawesi, Indonesia. The extraction of starfish is shown in this slide. Fresh samples of Arcastor typicus were frozen immediately after collection. The frozen starfish were thawing and freeze-dried to afford 9.68 grams of powder. The powder were extracted with methanol, filtered, and evaporated to give fraction 2, while the insoluble material were extracted with water, filtered, and freeze-dried to give fraction 1. UV spectrum of fractions 1 and 2 were measured and revealed that UV-absorbing substances were extracted in fraction 2. The water solution of fraction 2 was passed through an ODS column and washed with water. The column was then eluted with methanol. The first water flow from the column and water washings were combined and freeze-dried to yield fraction 2-1, and the methanol eluate was evaporated to give fraction 2-2. Fraction 2-1 showed the UV maximum at 125 nanometer, but this absorption was not detected in the UV spectrum of fraction 2-2. Based on the UV spectral data, fraction 2-1 contained UV absorbing substances, and therefore this fraction was used for the isolation of UV absorbing compounds from this starfish. And now I will discuss about isolation of UV-absorbing compounds from fraction 2-1. Fraction 2-1 was dissolved in water and centrifuged for about 5 minutes. The supernatant was subjected to SPLC using an ODS column with an isocratic condition of 0.1% TeV in water to separate into 5 fractions. All fractions were further purified by HPLC with 0.2% acetic acid in water to give 2 pure compounds together with 3 mixtures. Next, I will explain about the structural elucidation of compounds 1 and 2. Compound 1 was isolated as colorless powder. FAB-MS of 1 gave the ion peak at 245. High-resolution FAB-MS determined the molecular formula of 1 as carbon 10, hydrogen 16, nitrogen 2, and oxygen 5. Compound 1 showed a strong UV absorption maximum at 319 nanometer. The proton NMR spectrum of compound 1 revealed the presence of two methylens, one hydroxymethyl, one methoxy, and one N-methylene. The structure of compound 1 was confirmed as palatin by comparing proton NMR, UV, and MS data with those for the reported values, and this compound was first isolated from azoanthid Paletoa tuberculosa. Compound 2 was also isolated as a colorless powder. PubMS showed that compound 2 gave the ion peak at 289. Compound 2 have a molecular formula of carbon 12, hydrogen 20, nitrogen 2, and oxygen 6, which was determined by high-resolution PubMS. UV absorption maximum of compound 2 was detected at 331 nanometer. The proton NMR spectrum of compound 2 revealed the presence of two methylens, two hydroxymethyls, one methoxy, and two N-methylenes. The spectroscopic data for compound 2 were consistent with the reported values for Asterina 330, which was first isolated from the starfish Asterina pectinifera. And the conclusion of this presentation, two non-UV absorbing compounds belonging to the family of mycosporin-like amino acids, palatin and Asterina 330, were isolated from the Indonesian starfish Arcastra typicus collected at Tongkaina, North Sulawesi. And this is the first report of isolation of UV-absorbing compounds from Arcastra typicus. Studies on mycosporin-like amino acid of Arcastra typicus living in the other areas and the origin of mycosporin-like amino acids are interesting for the future subjects. That's all my presentation, and thank you very much.